I was born in 1985, and my earliest memory of a computer is the desktop PC that my dad brought home one day. As I recall, it was monumentally expensive, and it ran DOS, which stands for Disk Operating System, one of several computer operating systems that was popular before the age of the GUI, or Graphical User Interface, which is something that today we don't really think about. An operating system is a colorful and interactive and clickable thing. But back then, the graphical user interface was fairly revelatory. DOS was just a black screen with some text on it, and you navigated the files on your computer by looking at text and typing text. You booted software by writing a line of code that told the computer to do so. There was none of this fancy touchscreen business, and there wasn't even any of that fancy mouse-clicking business at this time. Apple's famous 1984-esque commercial, where a revolutionary hurls her hammer at a Big Brother-like figure on a massive TV screen, was alluding in some ways to breaking down the barrier between the common man and access to computers. Rather than needing to essentially learn the simple coding language required to access files using DOS, Apple's new Mac 128K personal computer had a graphical user interface. That 128K stood for the 128 kilobytes of RAM that the computer had, by the way. For comparison, 128 kilobytes is 0.000128 gigabytes. I have 8 gigabytes of RAM in the laptop that I'm using right now, though many machines have way more than that these days. So my modern Mac laptop is about 62,500% more powerful, at least in terms of RAM, of memory, than that original Mac desktop. But if you go back further than the mid-'80s, you'll quickly find that although there have long been personal computers that are contained within an individual unit that one person can access in isolation, this is not the organizational method that has been used throughout much of the history of computing. In fact, for the majority of the history of the computer, another method, that of access terminals, was more common. A modern computer typically has all the components, the processor, the RAM, the hard drive, the connectivity hardware, like the Wi-Fi and Bluetooth receivers, all tucked away inside a little box that you either hide under your desk or which is hidden within the chassis of your laptop. Old school computers, though, were massive in comparison to what we have today. They were built using different hardware, things like vacuum tubes instead of microchips, and magnetic tape instead of solid-state memory. And all that hardware was far bulkier than what we use today. As a consequence, you got a lot less bang for your buck in terms of size, but you also couldn't really store everything you needed in order to do anything useful within a box the size of a desktop computer, much less inside something like a laptop or a smartphone. So instead, the computer builders of the day built giant computers that took up entire rooms, or in some cases entire buildings, and used that as a central processing and storing hub. That central unit, be it room-sized or building-sized, was the computer. To utilize the computing resources available within that massive unit, you would sit down at a terminal, which would be connected to the computer. The terminal, during the period before computer screens, actually looked a lot like and functioned in largely the same way as typewriters. The early models of these so-called teleprinters or teletypewriters would actually print out information from the computer, and you could then type out words that would also be printed, showing you your input and the computer's output on the same roll of paper that printed out the top of the device, again, much like a typewriter. Later versions of this device allowed users to be more interactive, first replacing the roll of paper with very simple television screens, more or less, and then evolving into something that looks more like the precursor to modern desktop computers. Though the screens were usually of just one color back then, either green or white on black, and only text could be displayed at first due to the simplicity of the video cards that they were using. Even as cathode ray tube or CRT screens were added into the mix, this device was still usually what's called a dumb terminal, a machine that could access computing resources contained within that other larger machine, the actual computer, which might have been located in another room or even another building on a university or business campus. But the terminal was unable to do much of anything by itself. It was an access point, not a computationally capable piece of hardware itself. It was like a window that allowed you to look at what was happening inside the computer and even access what was happening inside the computer, but it was not a computer unto itself. It operated a bit like a modern computer keyboard. The keyboard is not a computer, it's just a means of interacting with the computer components. But in this case, you might have had a keyboard, a screen, and other techie accoutrements all in one place, while the computer was in a completely different place. And what's more, a bunch of terminals could be hooked up to the same computer. So you might have 5 or 20 terminals, all allowing different people to access the same shared computer resource. And you would then utilize time or processing cycles. There were different ways to break up these resources so that they could be shared equitably, so that you, as one person, were not hogging all of the computer's output. Later versions of these devices came to rely on an increasing amount of local, meaning on the terminal itself, not in a far-off room, processing power. Once microchips came along and became affordable enough to include in these devices rather than only inside the monolithic computers themselves, more responsibilities were given to the terminal, including display responsibilities like showing graphics and more than one color on the screen, but also number crunching responsibilities, which freed up the central computer so that more people could use it all at once, all tapping in from their separate, increasingly smart terminals, or as they were often called, fat clients, as opposed to the dumb terminals, or thin clients, of yesteryear. The word client, in this case, refers to an access point to a larger server, which is essentially what the computer-terminal relationship was. A server of resources and a client that received those resources. But as these systems evolved, that relationship was fleshed out, and the server-client relationship became the default mode of managing, first, intranets, the networks of early personal computers and centralized server computers within organizations and schools, and then the internet. Websites are contained on servers around the world, and when you visit one, files from that server are displayed on your screen, meaning your screen, be it on a computer or a smartphone or some other device, is the client that is accessing that server. In a lot of ways, then, our computing infrastructure has come full circle. We pulled inward for a while, ensuring that each personal device would be more than capable of doing all kinds of things in solitude, and that changed how we interacted with these devices, and how accessible they were, pretty substantially. But then we started reaching back out again, connecting these devices to each other and to more powerful computers elsewhere, and that changed things pretty substantially again, in a new way. Today, many of our devices are increasingly reliant on far-off systems to amplify the capabilities of the hardware we have on site, even if that doesn't always seem to be the case. They're still fairly sophisticated by Mac 128K standards, but they're more or less dumb terminals by the standards of modern computing. And that is what I want to talk about today. The evolution of our computational resources and the cloud-like superstructure that underpins a shocking amount of what we take for granted technologically today. You're listening to Let's Know Things. I'm Colin Wright. Let's Know Things is an independent, listener-supported show. If you're enjoying what you hear, one way to contribute is to become a patron on Patreon. If you go to patreon.com/letsknowthings, you can contribute however much makes sense to you based on your financial situation, based on how much value you're getting from the show. You can also contribute non-monetarily. You can leave a review up on iTunes or wherever you listen to this show. You can share the show with a friend who you think might enjoy it. You can share your favorite episode on Twitter or Facebook or Instagram or your social network of choice. And there are a half dozen or so other easy methods of contribution. If you're interested, you can find those at letsknowthings.com/contribute. All right, let's get back to the show. I'd like to kick off this episode with a quick summary of 4 articles instead of just one. The first comes from Bloomberg, and it's entitled, "Uber Paid Hackers to Delete Stolen Data on 57 Million People." If you pay attention to Tech World News, or if you've listened to some of the past episodes I've done on topics related to Uber, there's one I did last year that was called At What Cost, in which I addressed some of the more controversial, morally questionable decisions the folks in charge at Uber have made over the years. If you're aware of what they've done thus far, this piece of news probably won't come as much of a surprise. They are a company that has made a reputation of flouting the rules and sometimes getting away with it, and it's generally only when that flouting runs lawsuitably afoul of certain laws that they get caught. And as a consequence, many of their other gray area decisions are brought into the light. This article is about one such case. In October of 2016, hackers used login credentials that they gleaned from a private GitHub page used by Uber software developers. GitHub is a platform that allows multiple people to contribute to the development of software and other projects collaboratively. They breached that site, took login credentials from it, and used those credentials to access Uber's Amazon Web Services account, which is a cloud service that provides shared cloud processing capabilities and storage to the whole company. From that AWS cloud account, the hackers were able to steal names, email addresses, and phone numbers of 50 million Uber riders from around the world, along with the personal information of 7 million Uber drivers, including about 600,000 American driver's license numbers. What makes this case remarkable is that, first, Uber has been going on a charm offensive, trying to rebuild their reputation after booting co-founder and former CEO Travis Kalanick from his post. This revelation sets that back a bit, needless to say. And second, although the hack is far smaller than other recent hacks, like those perpetrated against Yahoo, MySpace, Target, and Equifax, this hack was covered up by the company. The former head of security for Uber apparently decided that instead of alerting the public about the breach, as is required by law, and adding to the company's existing pile of self-inflicted public troubles, they would simply pay the hackers $100,000 to keep quiet, which left those who had their information stolen potentially exposed, but also kept Uber from getting one more black eye in the press, till now at least. The second article comes from CNN, and it's entitled, "Pentagon Exposed Some of Its Data on Amazon Server." This story revolves around a hack that didn't happen, but which could have. A security researcher, a white hat hacker essentially, someone who looks for security holes and then helps the companies or entities in question plug them rather than taking advantage of them, noticed that the U.S. Defense Department, and more specifically, U.S. Central Command and U.S. Pacific Command, were storing data on their internal cloud databases that were, well, not so internal. The sites that would allow anyone to access these databases were open to the public and anyone who knew how to look for them. The data in question here wasn't super sensitive or confidential. It was basically a bunch of articles and blog posts and such, scraped from the internet and put into a searchable database. It was all publicly available information that was organized for folks within those government entities to more easily make use of. But this revelation raised warning flags about the security measures these entities were taking. If they were leaving this one access point to their internal cloud systems open, chances are they're probably leaving others open as well, and the others might contain assets of a more sensitive nature. The third article comes from VentureBeat, and it's entitled Google Pixel Buds Review. Google Assistant makes a home in your ears. There's no hacking in this article. Instead, it's a review of Google's new wireless earbuds, a product that was introduced to compete with Apple's popular AirPods, but which was promoted using some very different framing than Apple opted for. Instead of focusing purely on the wireless Bluetooth capabilities, they demonstrated the Pixel Buds instant translation capabilities. Capabilities that are still reliant on your phone to use optimally, but which made them seem magic and differentiated from other options on the market when they were demonstrated. That special gimmick claimed by these headphones, however, is reliant on a strong internet connection. The earbuds themselves do a little bit of work, and so does your phone, but a great deal of the processing, from audio signal to language, from language to another language, and from that new language to audible sounds in your ears, that takes place in the cloud. It's not a magical device, it's a device that makes it easier to utilize the power of supercomputers for translation purposes without having to take your phone out of your pocket. And finally, the fourth article is from CNBC and is entitled Microsoft Azure is growing faster than AWS, and big brands are behind the expansion. This piece is about how Microsoft is leveraging slightly lower prices and its existing relationships with corporations in an attempt to outcompete their competitors in the cloud computing world, namely Google and Amazon. Amazon is the giant in this space, with their AWS offerings running an estimated 10 times the total computing capacity of the 14 next largest cloud providers combined. But Microsoft is a very distant second, trailing way behind Amazon, and they are doing their best to stay ahead of the third place contender, Google. Part of what seems to be helping Microsoft in that respect to stay ahead of Google, but also to continue gaining on Amazon year over year, is that both Google and Amazon are considered by some corporations to have potential conflicts of interest in this space. Microsoft sells software to corporations, so their interests are largely aligned with those corporations. But Amazon sells all kinds of stuff to all kinds of people, and Google sells ads. These latter two companies, it's suspected, might use the data they gather from corporations for purposes that are not in the corporation's best interest. That, combined with Microsoft's existing relationships in the corporate software space, is seen as one of Azure's greatest assets, above and beyond the relative ease of use of the service compared to Amazon's AWS and Google's cloud. So you might have noticed the red thread running through all of these pieces. The cloud. Whether we're talking about hacking or government security or magic-seeming computer technology or corporate infrastructure and sales, the cloud has tendrils in just about everything these days. Indeed, it would be difficult in the modern world, especially in cities, to not use the cloud in some way every single day, even if just passively. This is in part because of how our computing infrastructure has evolved, and in part because of how our needs and requirements have changed. And remarkably, this is a technology that, though not a new idea entirely, only emerged in its modern incarnation in mid-2006. So our dependence in this space has aligned almost perfectly with the emergence of other, now ubiquitous technologies, like social networks and the smartphone, both of which arrived at about the same time. But let's backtrack. What is the cloud? If you look up the term cloud computing, you're likely to find a definition that reads something like this, which is the first paragraph from the Wikipedia entry on the topic. Quote, Cloud computing is an information technology paradigm that enables ubiquitous access to shared pools of configurable system resources and higher-level services that can be rapidly provisioned with minimal management effort, often over the internet. Cloud computing relies on sharing of resources to achieve coherence and economy of scale, similar to a utility." End quote. So that's actually a pretty well-written, fairly informative block of text, but it's less valuable to someone who is not already familiar with things like configurable system resources and how utilities are managed and distribute resources. I personally think the concept is a little easier to understand if you look at how the modern incarnation of the cloud came into being. In 2006, Amazon relaunched a public-facing version of its AWS offerings. AWS stands for Amazon Web Services. Amazon, the world's largest online retailer, was already using a version of this system internally. They developed a platform that would essentially allow them to build server farms, big buildings filled with powerful computers that they could tap into and utilize from anywhere via the internet. They could build them anywhere and then lash those server farms together, even those widely separated by geography, into one big pool of computing resources. They could then carve up that big pool of processing power and storage and memory and use little bits or big bits in whatever size or shape might be necessary for their needs. They were also able to carve up these computing resources into smaller virtual computers. So they could take 10,000 computers worth of computer power and divide it into 4 massive supercomputers, or 2,000 just regularly big and powerful computers, or 10 million smaller computers, or whatever combination of these sizes made sense for their needs. These virtual machines could be of any size or shape or combination of sizes and shapes. This was necessary for Amazon because they had an ever-scaling need for computational resources to serve their website and the commercial platform that was built upon it. The Amazon marketplace through which they sold things, but also through which other people sold things on their site and through which affiliates signed up and earned a cut, and so on. And all of these things required different types of resources and attention. The AWS system and all the subsystems it contained, like Amazon Elastic Computer Cloud, or Amazon EC2, as it's usually called, allowed them to do this. And it allowed them to do so basically by visiting a website and telling it what they wanted from that big pool of resources and how they wanted to use it. But a couple of Amazon employees wrote a proposal back in 2002 that indicated the company might be able to take these same services and sell them to the public. Rather than Amazon and only Amazon benefiting from these nearly infinitely scalable computing resources, they could provide storage or processing power or whatever else to people and companies who wanted to, for instance, host a big online marketplace from secure server farms rather than their office-based, less secure servers. Or maybe someone would want to serve applications like Microsoft Office-style software suites to their employees or their customers via the internet. These virtual machines carved out of the massive quantity of computing resources Amazon had on hand could allow them to do this, and would keep them from having to buy, store, and maintain any of the hardware required themselves. It was also possible that a company would just want to store things like their customer database or their shared marketing resources to which they wanted all employees to have access online. Whatever they wanted would be available to everyone who had the right login info at all times from anywhere, just like when they used their own servers. But it would be much cheaper and far more scalable if they decided that they needed more at some point, and they would not need to buy a warehouse and keep upgrading a bunch of computers in order to have these benefits. By the end of 2010, all of Amazon's many online assets and services had been moved over to AWS to allow them to be more efficient and scalable internally, alongside their burgeoning external AWS offerings. By the beginning of 2016, AWS was, as a separate business from the Amazon marketplace, more profitable than all of Amazon's North American retail business combined. AWS is predicted to bring in $13 billion in revenue in 2017, which is an astounding amount of money, but even more astounding in many ways is the sheer number of customers and how many computing resources they provide to those customers each year. Amazon AWS provides virtual servers and online hosting of applications, domain name services, virtual private clouds, private data centers, elastic traffic load balancing, elastic network bandwidth, content delivery, customer service resources, short-term data storage, high redundancy long-term data and media storage, scalable databases, in-memory caching for web applications, data warehousing, mobile app services, sign-in and authorization services, operating system virtualization, email and SMS message distribution, code deployment services, monitoring services, software compliance services, encryption services, publishing and analytics and marketplace services, among many others. So Amazon got there first, and they figured out how to utilize those computing resources that they had bundled together and made carvable into an infinite number of different shapes, how to use those in many different ways. But many other companies, including several of the biggest technology companies in the world, have at least small slices of the larger cloud computing pie. And that's led to an even greater diversity of use cases and industries utilizing these types of technologies. Cloud computing is an important concept to understand, even if you're not involved in development or software engineering, because these services, the combination of them, has changed the world around us. It has, in many ways, enabled the world that we live in today. Many of the websites and apps that we interact with every single day, in some cases many times a day, are enabled by cloud services. Yes, Facebook would probably still exist without Amazon or its competitors, but Netflix uses AWS. It requires massive amounts of computational power and bandwidth to operate. And without that scale, without being able to buy that many computing resources as a service, they would have needed to build their own server farms, which is what Facebook did and continues to do at great expense. Though conceivably, had these cloud services existed in their current incarnation back when Facebook got started building their own server farms, they might have chosen to do otherwise. For most companies, the initial huge investment of buying their own hardware and cloud infrastructure just doesn't make sense compared to the convenience and savings of using the cloud as a service instead. So if you think about all the apps that you use every single day, you can safely assume that all of them are making use of the cloud in some way. Whether it's to parse and process your inputs, to keep track of high scores, to save or transfer your files, to populate your timeline with user-generated content, or just to get that app in the first place, to download it onto your device. And the vast majority of these apps are created by companies that do not have the financial wherewithal to build their own server farms, their own big old buildings filled with high-end computers that are lashed together to operate as a bigger, flexible, scalable pool of computing resources. The cornucopia of digital options that we have, from apps to games to movies and music, the streaming, the downloading, the sharing and storing, the emailing and texting and Snapchatting, it's all enabled by the cloud. The power to do all these things is lent to us by a global network of computers that are connected to each other, their combined power optimally delegated by clever software, ensuring that even tiny startups can leverage big resources and get their project out into the world. And that even you and me, with our laptops and smartphones and audio devices, can tap into these resources at essentially zero cost in many cases, and without even realizing what's happening under the surface to make it happen, without realizing that we are using the cloud to begin with. So part of what's remarkable here is the scale of the power that is being leveraged. And part of what's remarkable is how big this industry has become in such a short period of time. But perhaps the most remarkable facet of the cloud is what it allows us to do. The tiny magical things that are the products of this globe-spanning, always-on, immensely accessible, all but invisible network of computers. The aforementioned Google Pixel earbuds contain a microphone that allows your phone to capture your voice. And in real time, as you speak, your words are sent as audio data to software based in the cloud. So as you're speaking, your voice is being uploaded, and a program stored on the cloud is using supercomputer strength to process your words into bits that it can then use to derive meaning from what you're saying. It compares your bit words to all the other information in its massive database of words, and uses that to string your words together into a sentence, which are then translated into another language, and that data is converted into audio, which is, within seconds or a fraction of a second, sent back to you via your internet connection and projected into your earbuds. That same audio information could also be used as a search query, which that cloud-based software would instead use to trigger its search algorithms and figure out what it is you're trying to find out or discover before returning some top answers or suggestions to you, again, all within a split second. There's way more than that happening behind the scenes. Many steps, many programs, and sub-programs and sub-sub-programs involved along the way. Lots of algorithms, lots of what we could probably at least semi-accurately call artificial intelligence. But to us, wearing those earbuds, all we're doing is talking into space, into thin air, and within a reasonable time frame, the amount of time it might take a person to hear us and respond, we receive data pulled from the biggest depository of data that's ever existed, the internet. Or we hear our words spoken back to us in another language. Or maybe we hear the song that we requested. Like a genie in our ears, we magically receive what we want, what we were hoping for. That's the idea, at least. These earbuds, and most other earbuds in this product category right now, are receiving very mixed reviews. And like most products based on audio interfaces, there are still very tenuous results in terms of what's fully baked and what's working most of the time. But the concept is sound, and it's frankly stunning that it all works as well as it does. It's remarkable that I can ask my phone for knowledge, and it can provide me with relevant knowledge, all using an input format that's natural to me, but which requires hardcore computational resources for it to glean any kind of information from. The cloud is allowing us to take what's already there and leverage it better. It allows us to benefit from economies of scale, meaning a handful of companies can go on a building spree, scaling up their infrastructure, building tons of increasingly powerful and efficient and effective server farms around the world. And all the rest of us can benefit from the fact that they're able to reduce the costs of building and maintaining these structures and networks over time. If I tried to build a server farm, it would be smaller, less powerful, and less efficient than what Amazon could build. Even if I had enough money to do such a thing, they would have an advantage because they build so many of them. They can get discounts on parts. They have the ability to tweak and experiment and learn over the course of many such projects. And they know they can reach a large customer base, which allows them to make better investments up front rather than cutting corners. This allows for overall cheaper and higher quality resources for everyone, resources that are becoming ever more necessary, but also ever more useful, as they're carved up and utilized in different ways to serve different needs and markets, as they become more elastic, more form-fitting, and less wasteful. There are, of course, valid reasons for concern about this new state of affairs. The CIA uses AWS for many of their internal computational power and storage requirements, alongside CENTCOM and other government agencies. These resources are divided up in such a way that it's not like you can just hack one computer and you've suddenly got access to everyone on the network. But while increased reliance on one way of doing things is great for economies of scale, it's not so great for security-based diversification. Meaning, if someone could figure out a way to knock out AWS services, a lot of the world's infrastructure, particularly online, but also some government agency resources and things like that, would be unavailable, in addition to all of the other services that rely on AWS in some way. So Netflix would be down, but so would some portion of the CIA's resources. And it wouldn't even take a malicious act to make this happen. AWS and other cloud services have gone down before. Sometimes just chunks of the bigger network, a single or a few regions, sometimes substantially more than that. In some cases, this is the result of what amounts to online bad weather, and sometimes it's human error. An outage in February of 2017, which led to downtime for companies like If This Then That, Quora, and Trello, was blamed on human error, and that was similar to past outages that took down Instagram and Vine and the Internet Movie Database. The outward-facing result is the same in either case, whatever the reason for the outage. And that can impact huge chunks of the global human population, whether it's a hacker attack, or human error, or just a bug. Most cloud services live and die based on their uptime reputation, so they tend to do a pretty good job overall, all things considered. There's a lot that can go wrong, and they do a good job with their redundancy and their security systems to ensure that that doesn't happen very often. But it's difficult to look at this type of setup with so many products and services dependent on what amounts to a single point of failure and see anything but a weakness alongside the many, perhaps far more obvious, strengths. It's also worth mentioning that our increased reliance on the cloud is exposing more private information to more entities than we might realize. When we speak into our devices, on calls or to our virtual assistants, or to translate some words into another language, that information is sent somewhere. In many cases, that information isn't even heard by human ears, it's parsed by software. There's just so much of this kind of data that to do anything else wouldn't make sense. It would not be efficient enough to have a bunch of humans sitting there listening to all this uploaded audio. But sometimes that information is stored somewhere. And even when it's not done for malicious purposes, when it's just being cached for our own convenience, there's still a chance that that information, that data, that audio, could end up in the wrong hands at some point. This is what we saw with the Uber hack. Information we entered into our Uber app was stolen by hackers. There are many different ways that a similar theft could have happened in the past using other storage mechanisms. Burglars can steal filing cabinets full of customer information. But because these services are so ubiquitous, the incentive to figure out how to bypass and abuse them is quite high. The security expert who found CENTCOM's scraped article database knew where to look because CENTCOM was using AWS. And if you know the service well enough, you can figure out how to access other people's stuff if they're not super careful about their security procedures. None of this means that you should throw away your smartphone and run off to live in the wilderness, but it's worth being aware of what's happening around you, of where all this information goes, how it's being used, and why, sometimes, it ends up going places you would prefer that it did not go. Privacy settings can help you keep certain types of information off of search engines and timelines, and you can toggle certain switches to keep Google and Amazon and Facebook from tracking you around the web so obsessively. But just by using most modern technologies, you're automatically putting a lot of yourself, private information potentially, out into the ether. It's still fairly unlikely that anything bad will happen to you as a consequence of this, but the chances of your information being stolen, your conversations heard, your queries saved at some point is not zero. Another facet of this conversation is the burgeoning Internet of Things, the network of devices that are connected to each other and to the Internet that reside around our cities, our neighborhoods, and our homes. Most of these devices work something like the old school FAT terminals I mentioned in the intro. They themselves have tiny, somewhat weak processors, and they can do some stuff all by themselves, but most of what they do is done in the cloud. And they are mostly just the portal through which we receive the results of that computational wizardry. The Google Home or Amazon Echo that we ask questions or have tell us the weather in the morning is pulling all that information from the cloud, which the software in the cloud snags from the internet. Many of these devices used what's called fog computing, or sometimes edge computing, which makes use of these semi-smart terminals to do computational things without having to reach back up into the cloud, or without having to reach up quite so far or so often. So your smart home light bulb might be able to do its own heavy lifting when it comes to receiving a signal from you via your smart home audio device or smartphone app to turn itself off or change colors. This allows these cloud-connected devices to reduce latency the time between you asking for something and getting it, which can be an issue with certain tasks, especially those that seem strange when they don't happen immediately. Turning off a light bulb and having that light bulb needing to reach back up into the cloud to obey that instruction would be a little bit weird. So it makes sense to have a microprocessor of some kind in that light bulb. Another concept, which I believe I've mentioned at some point in a past episode, is that of the personal cloud, essentially a cloud of devices that you wear, that you have on you. Just as all these servers in far-off places work together and share resources to operate optimally, your devices can do the same, if to a lesser and currently less impressive degree. Your smartphone and smartwatch and your smart headphones can make up a very small cloud that do things together, using fog computing much faster than they might be done if you needed to tap into the larger, world-spanning cloud all the time. As this personal cloud expands to include things like smart clothing and shoes and glasses or contact lenses, our capabilities could also improve, and the amount of overall computing power we have at our fingertips, perhaps literally, and the ways we're able to use that power could also increase. Again, we're already seeing this to some degree in things like our headphones. They use the superior processing power and connection to the internet provided by our smartphones. Add more devices into the mix, and you have more processors, more storage space, and more inputs and outputs, cameras and speakers, things that vibrate and change color, and so on. Those same security issues apply here, of course, and arguably even more so as our personal clouds, at least at the moment, are nowhere near as secure as the server farms and other assets that make up the larger, ultra-high-end cloud that serves as the backbone of the modern technological world. I personally tend to be bullish on things that tie us together more effectively, especially when that weaving brings with it all kinds of other benefits that couldn't be easily accomplished or accomplished at all in any other way. The cloud is a new danger, a new vulnerability, but it's also empowered us so immensely that it's difficult to imagine what the world might look like without it. We'd all have far fewer options and resources, almost certainly, but the internet and our technologies as a whole would be far less expansive and capable. They wouldn't be able to hold up under the weight our information age civilization has rested upon them. No matter the benefits, though, it's a good idea to keep your eyes open and maintain a healthy awareness of potential downsides and abuses. These technologies are enablers today, but they could just as easily become unscalable walls built between established players in given fields and those who wish to challenge them, but who lack the proper resources. Imagine if today's cloud companies closed up shop and decided to use their scalable resources internally only, or dramatically increase their prices. That would give corporations like Amazon and Microsoft and Google massive advantages when facing off against anyone who might challenge them in the future. It might price anyone who couldn't afford the new, substantially higher startup prices out of the market from the beginning before they even become a threat. There's no sure way to keep such things from happening, of course, but understanding the technologies at play and how they influence everyday life at least puts us in the position to recognize when it's happening. And from there, we can potentially leverage whatever influence we might have, be it political or market-based or otherwise, in order to counter the potential weaponization of what's become the largely positive and beneficial lifeblood of the modern world. If you are enjoying this podcast, there are many different ways that you can help support it. One of the simplest is probably becoming a patron on Patreon. If you go to patreon.com/letsknowthings, you can contribute however much makes sense to you and your financial situation, and based on how much value you're getting out of the show. And that will gain you entry into the community there, some extra content throughout the week, and things of that nature. I am hoping to, in the relatively near future, move away from doing all sponsors on this podcast and just going completely listener-supported. And one of the best ways to ensure that I can do that more confidently is to become a patron on Patreon. You can also contribute monetarily via Venmo or PayPal, links to that at letsknowthings.com/contribute. And you can also buy one of my books if you enjoy books. You can find a full list of those at colin.io. Non-monetary contributions, of course, are also very much appreciated. Leaving a review on iTunes, sharing the show with a friend, sharing your favorite episode on your social network of choice. Every and all effort in this regard is very much appreciated. A huge thanks to everyone who has already contributed in some way. The book that I'd like to recommend today is one that I was actually surprised to find I hadn't recommended already. This is a book that was written several years ago by some very good friends of mine, Josh Milburn and Ryan Nicodemus. It's entitled Everything That Remains. And this is a book essentially about the journey from living kind of a corporate lifestyle and focusing on consumer therapy, essentially, and moving from that into a place where you're more focused on the important things, and doing so, in this case, utilizing the philosophy of minimalism, of focusing on the important stuff, and eschewing the superfluous so that you have more time, energy, and resources to apply to the most important things and activities and people in your life. The book is very well written. It's hilarious. It's written from Josh's standpoint, and then Ryan intercedes in the footnotes with his commentary, which is just delightful. And if you or anyone in your life is kind of looking to make a pivot, to realign the way that they live with their actual philosophy, to start the new year with a new way of looking at things, this would be an excellent book, either for yourself or as a gift to that person who fits that criteria in your life. That title again is Everything That Remains by Joshua Fields Milburn and Ryan Nicodemus. You can find out more about me and my work at colin.io. You can find my blog at exilelifestyle.com. And you can find the show notes for this episode and every episode at letsknowthings.com. Feel free to reach out on social media and say hello. I am at Colin is my name pretty much everywhere. Thank you so much for listening. My name is Colin Wright, and I will talk to you again next week.